Okay, so I just want to review some of the formulas that we went over last time, and this is one of them. Well, not yet. This isn't one of the ones that you've seen, but you will see one of the ones that we've seen in a couple minutes because I'm going to kind of derive it. So acceleration is equal to change in velocity over change in time, which, remember, we have velocity after a certain amount of time minus initial velocity over time. So let's rewrite this. And here's what we have, and now we're going to do some rearrangements. Sorry, that's a t. And we're going to do some rearrangements. So I've got AT is equal to v minus u, and if you add the u to both sides, then you have v is equal to AT plus u, or the way Cambridge writes it, v is equal to u plus AT. So if you ever get stuck on an exam, whether it's a mock or the AS exam, you can always go back to this and just derive it. Take it step by step and take it to that formula. And this one is interesting to me because it makes complete sense. So S is displacement, and displacement is distance in a certain direction, and it's in meters, okay? So if we add our two velocities, we've got the final plus the initial, and we multiply it by time, and I'm going to show you the reason why we multiply it by time in a moment. But we want the average. We're averaging these two velocities, so we're going to divide it by 2. Okay, so let's go ahead and put our units in. So S is meters, and we've got seconds, and we've got meters per second plus meters, whoops, I drew a 2 there, I don't know why. Okay, plus meters per second divided by 2. Well, these seconds are going to cancel. So we're just going to have what's the average distance if we divide it by 2. So that's why this formula works. Meters per second, seconds, and then the seconds in the denominator here are going to cancel. If we divide it by 2, then we have the average. And finally, we're going to come up with the last one. So I'm going to multiply by the reciprocal here. So I've got 2s over t minus u equals v, and if I substitute this formula into this formula and by the way, this formula is very useful if you don't have the final velocity or the velocity after a certain amount of time, or t. So now if I just do a rearrangement, and I'm going to try to isolate s, but first I have to get the u on the other side. Minor error was made before, so here is that other formula, and I went ahead and rearranged this one. So now we're going to add the u, so I'm going to set these equal to each other, so u plus AT is equal to 2s over t minus u. If I add the u, then I have 2u plus AT is equal to 2s over t. Let me switch markers, one moment. And I'm going to multiply the t, so I've got 2. I'm not sure if I'm fond of this color, but hopefully you can see it. ut plus at squared, divide the 2, over 2 is equal to s, and s is equal to 1/2. I'm rearranging these, I'm just switching them around, okay? At squared plus ut. And that's a formula you can use if you don't have the final velocity. It's very handy, and you'll be using it probably the majority of the time.